Arctic News. Monday, June 2, 2025. Arctic Blue Ocean Event 2025. Update June 2025. There are many conditions that contribute to higher temperatures. Temperatures have recently been rising at a rate that is unprecedented in history. The temperature rise may accelerate further, and there are many conditions and mechanisms that point at further acceleration. Earth's high energy imbalance has more than doubled in recent decades. Image below, Mauritsen, 2025. Below is a video in which Paul Beckwith discusses the study. The video has the title, 57 Scientists, at 46 Institutions, co-author 4-page paper ignoring almost all James Hansen's EEI work. Concentrations and emissions of greenhouse gases are high and rising. The image below shows recent carbon dioxide, CO2, concentrations at Mauna Loa, Hawaii. The image below shows monthly CO2 at Mauna Loa, Hawaii. Black Swan Event 1. Crossing the clouds tipping point. The image below shows the same monthly data, this time from May 2022 through May 2025, with a trend added that warns about 1,200 parts per million, ppm, getting crossed in 2028. Crossing the clouds tipping point at 1,200 ppm CO2 could, on its own, push temperatures up by 8 degrees Celsius globally, in addition to the temperature rise caused by the extra CO2 to reach the tipping point. Moreover, the clouds tipping point is actually at 1,200 ppm CO2e, carbon dioxide equivalent, so when taking into account the impact of growth of other gases, strengthening feedbacks, and further mechanisms, this tipping point could be crossed much earlier than in 2028, potentially as early as in 2026. Crossing the clouds tipping point early could be regarded as Black Swan event, since climate models typically ignore such an event. Black Swan events are events that are unforeseen in climate models. Such events can suddenly and unexpectedly increase temperatures. While there have been many warnings about such events, they are typically ignored or minimized in climate models. In fact, many warnings about acceleration of the temperature rise are ignored in climate models. 8 Black Swan events are identified in this post. Since Black Swan events are inherently unforeseen in climate models, there is little or no discussion about them, and there may be many more of them on the way than are mentioned here. The situation is also dire regarding further conditions than CO2 concentrations and emissions, i.e. they are also high regarding further gases and aerosols, also fueled by fires and war. While sea ice is low, the jet stream is distorted, AMOC is slowing down, and sunspots are high. On top of this, there are numerous self-amplifying feedbacks that can dramatically accelerate the temperature rise, and mechanisms are in progress that increase temperatures, such as reductions of aerosols that are currently masking the temperature rise. Not only are many of the feedbacks self-amplifying, strengthening feedbacks and changing conditions can also amplify each other, e.g. a freshwater lid can form at the surface of the North Atlantic, and a distorted jet stream can combine with hurricanes to cause more ocean heat to get pushed toward the Arctic Ocean underneath this lid, and subsequently speed up sea ice loss and cause eruptions of methane from the seafloor of the Arctic Ocean. Formation of a freshwater lid at the surface of the North Atlantic. There are further tipping points, in addition to the above-mentioned clouds tipping point. Tipping points include loss of Arctic sea ice and loss of the latent heat buffer as Arctic sea ice disappears. Crossing such tipping points can abruptly and strongly increase temperatures and thus trigger crossing of further tipping points. Black Swan Event 2. Early El Niño. Models do not predict the next El Niño to appear soon, as illustrated by the image below. Nevertheless, the next El Niño may nevertheless emerge earlier, even a lot earlier than expected, and it may be a strong El Niño. An indication of this may be the sharp recent increase in sea surface temperatures in Niño 3.4, an area in the Pacific, inset, that is critical to the development of El Niño. After a sharp and sudden rise over a few days, the sea surface temperature in the Niño 3.4 area reached 27.87 degrees Celsius on June 2, 2025, 0.26 degrees Celsius above 1982 to 2010, image below. Black Swan Event 3. Low global sea ice. 1. Feedback of high temperatures and high concentrations of greenhouse gases is loss of sea ice. Polar amplification of the temperature rise is hitting the Arctic hard, and is also causing dramatic loss of Antarctic sea ice. Global sea ice area has been very low over the past few years, as illustrated by the image below, something that wasn't anticipated in climate models. Low global sea ice comes with dramatic loss of albedo, i.e. a lot of sunlight was in previous years reflected back into space and it is now instead getting absorbed by the sea surface. On June 2, 2025, global sea ice area was 17.52 million square kilometers, lowest on record for the day. The fact that global sea ice area currently is lowest on record for the day can also be regarded as a black swan event, the more so since there currently is no El Niño present, but instead ENSO neutral conditions dominate. Importantly, low global sea ice area does increase ocean heat, as discussed next. Black Swan Event 4. Loss of lower clouds. Low global sea ice area comes with albedo loss and this causes more heat to be absorbed by oceans. Higher sea surface temperatures result in loss of lower clouds, further reducing albedo and thus accelerating the temperature rise. This extraordinary loss of albedo may result in a blue ocean event in the course of 2025, as discussed next. Black Swan Event 5. Blue Ocean Event. On June 2, 2025, Arctic sea ice area was second lowest on record for that day, only slightly higher than 2016. Significantly, 2016 was a strong El Niño year. On June 2, 2025, Arctic sea ice area was 0.44 million square kilometers lower than on June 2, 2012. If the sea ice area will be 1.34 million square kilometers less than 2012 on September 12 this year, there will be a blue ocean event. From earlier post. Black Swan Event 6. Loss of latent heat buffer volume and thickness are two further measures to assess the health of Arctic sea ice, and they are critical in regard to the latent heat buffer, which decreases as sea ice, permafrost, and glaciers disappear. Latent heat is energy associated with a phase change, such as the energy consumed when ice turns into water. During a phase change, the temperature remains constant. As long as there is ice, additional heat will be absorbed by the process of ice turning into water, so the temperature doesn't rise at the surface. From albedo, latent heat, insolation and more. The amount of energy absorbed by melting ice is as much as it takes to heat an equivalent mass of water from 0 to 80 degrees Celsius. The energy required to melt a volume of ice can raise the temperature of the same volume of rock by as much as 150 degrees C. From earlier post. Warmer water flowing into the Arctic Ocean causes Arctic sea ice to lose thickness and thus volume, diminishing its capacity to act as a buffer that consumes ocean heat entering the Arctic Ocean from the North Atlantic. Arctic sea ice volume, click to enlarge. His means that, as sea ice thickness decreases, a lot of incoming ocean heat can no longer be consumed by melting the sea ice from below, and the heat will therefore contribute to higher temperatures of the water of the Arctic Ocean. Similarly, there is a point beyond which thawing of permafrost on land and melting of glaciers can no longer consume heat, and all further heat will instead warm up the surface. The image on the right shows that Arctic sea ice volume has been at a record daily low for more than a year, reflecting loss of the latent heat buffer. Loss of the latent heat buffer constitutes a tipping point. Beyond a certain point, further ocean heat arriving in the Arctic Ocean from the Atlantic Ocean and the Pacific Ocean will no longer be able to be consumed by melting sea ice from below. Black Swan Event 7. Seafloor methane eruptions. Further incoming heat therefore threatens to instead reach the seafloor of the Arctic Ocean and destabilize methane hydrates contained in sediments at the seafloor, resulting in abrupt eruptions of huge amounts of methane, in turn threatening increased loss of permafrost, resulting in additional emissions, as illustrated by the above image and the image below. The buffer is gone, from earlier post. Heat danger is especially large in the East Siberian Arctic Shelf, ESAS, which contains huge amounts of methane and which is hit strongly by the temperature rise, as described in earlier posts such as this one. Methane in the atmosphere could be doubled in March 2026 if a trend unfolds as depicted in the image below. A rapid rise is highlighted in the inset and reflected in the trend, which is based on January 2023 to October 2024 methane data, as issued in February 2025. Double the methane in March 2026. Image from earlier post, click on images to enlarge. Rise like the one depicted in the trend could eventuate as rising ocean heat destabilizes methane hydrates contained in sediments at the seafloor of the Arctic Ocean. The temperature rise in the Arctic would accelerate since the methane would initially have a huge impact over the Arctic and cause depletion of hydroxyl, of which there is very little in the atmosphere over the Arctic in the first place. Such a rise in methane would also dramatically increase concentrations of ozone in the troposphere and concentrations of water vapor in the stratosphere. Black Swan Event 8. Water vapor. The IPCC has failed to warn about the size of the temperature rise. Higher temperatures imply stronger feedbacks, such as stronger evaporation resulting in both a lot more water vapor and a lot more heat getting transferred from the surface to the atmosphere. Much of this will return to the surface with precipitation such as rain and snow, but 7% more water vapor will end up in the atmosphere for every degree Celsius rise in temperature. Moreover, water vapor is a potent greenhouse gas that will increase temperatures, and it is a self-amplifying feedback that can strongly contribute to further acceleration of the temperature rise. From April 2024 post, click on images to enlarge. As illustrated by the above image, the temperature rise from pre-industrial to February 2024 could be as large as 2.75 degrees Celsius, which corresponds with almost 1/5 more water vapor in the atmosphere. Scientists are shocked to see sea ice disappear. In the video below, Guy McPherson reflects on news that scientists are shocked to see sea ice disappear. Climate emergency declaration. The situation is dire and the precautionary principle calls for rapid, comprehensive, and effective action to reduce the damage and to improve the situation, as described in this 2022 post, where needed in combination with a climate emergency declaration, as discussed at this group. Links. Earth's energy imbalance more than doubled in recent decades, by Thorsten Mauritsen et al., 2025,